Hello everyone. So in this video, we will determine if the function is continuous or not at a point. So first, we will determine the three conditions of continuity of a function at a point. So first, let's define continuity of a function at a point. So a function f is continuous at a point if and only if the limit of f of x as x approaches to c is equal to f of c. Then the function f of c is continuous at a number c, f, and only if the three of the following conditions hold. First, f of c exists. Then the second, the limit of f of x as x approaches to c also exists. And the third condition is the limit of f of x as x approaches to c is equal to f of c. So these three conditions should be satisfied so that we can say that our function is continuous at a point. So now, let's proceed to example 1. So using the definition, determine whether the function f of x, so we have a piecewise function, so negative x squared plus 4 if our x is less than or equal to 3, or 4x minus 8 if x is greater than 3 is continuous at x equals 3. Then justify the conclusion. So in this function, we will apply the three conditions to determine if a function is continuous or not at x equals 3. So first, so we will determine if our f of c exists. So our f of c is equal to 3. So we have f of 3 is equal to, so we use the negative x squared plus 4 as x is less than or equal to 3. So we have negative 3 squared plus 4. So we substitute 3 to our value of negative x squared. So the answer is negative 5. So as we can see, our f of c at x equals 3 is defined at negative 5. So now let's proceed to condition 2 because our f of c exists. In condition 2, we will determine the limit from the right and limit from the left. If the limit is equal, so we can say that our limit of f of x as x approaches to 3 exists. So now, we will determine first the limit of f of x as x approaches to 3 from the left. So equal to, so we use the function less than 3. So the less than 3, which means that we will use negative x squared plus 4 if x is less than or equal to 3. Then we will substitute 3 to our variable x. So we have negative 3 squared plus 4. So equals to negative 5 because 3 squared is 9 and plus 4. So negative 9 plus 4. So we have negative 5. So the limit from the left is equal to negative 5 as x approaches to 3. Then we will also determine the limit from the right of f of x as x approaches to 3 from the right. So limit of f of x as x approaches to 3 from the right is equal to, so we use the function 4x minus 8 if x is greater than 3 because from the right, so it should be, so our function is greater than 3. So we use 4 times 3 minus 8 is equal to 4. So 4 times 3, our x, so we substitute the 3 to our variable x. So we have 4 times 3 minus 8 is equal to 4. So as we can see, the limit from the right and limit from the left is not equal. So our limit does not exist. So therefore, we don't need to proceed to condition 3 because the second condition is not satisfied. Therefore, we conclude that the limit of f of x as x approaches to 3 does not exist. Thus, f of x is not continuous at 3 because the condition 2 is not satisfied. So now, let's proceed to the graph. So we look at the graph of our function f of x. So the graph of f of x is shown in the figure below. So this is our graph of f of x. So as you can see that in our graph, so we have a jump discontinuity. Although our f of a exists, but the limit does not exist. So that our function is not continuous at x equals 3. Now, let's proceed to example 2. So let's determine if our f of x equals to x squared minus x minus 2 over x minus 2 is continuous or not at x equals 0. So we will apply the three condition of continuity of a function. So first, we will determine f of c, how f of c exists. So we have to check the three condition of a continuity of a function. So first, so if x is equal to 0, then our f of 0 is equal to 1. So we substitute 0 to our function. So 0 squared minus 0 minus 2 over 0 minus 2. So we have negative 2 over negative 2. So we get positive 1. So negative 2 divide negative 2. So we have positive 1. So we can say that our f of c or f of x is at x equals 0. So we have 1. So we can say that our f of c defined. So our f of c defined. So let's proceed to condition 2. So in condition 2, we will determine the limit of f of x as x approaches to 0 if this limit exists. So we have the limit of x squared minus x minus 2 over x minus 2 as x approaches to 0. So first, we will factor out x squared minus x minus 2 so that we can cancel out the denominator. So we have the limit of x minus 2 times x plus 1 over x minus 2. So now, cancel out x minus 2, then we have the limit of x plus 1 as x approaches to 0. And it is equal to 1. So we substitute 0 to our variable x, so we get 1. So 0 plus 1, so we have 1. So as we can see that the condition 2 is also satisfied because the limit of f of x as x approaches to 0 exists. Then, so now let's proceed to condition 3. The condition 3 is f of 0 is equal to the limit of f of x as x approaches to 0 because our f of x is equal to our limit of f of x as x approaches to 0, and it is equal to 1. So therefore, our three condition is satisfied at x equals 0. So we can conclude that f is continuous at x equals 0. So next, so example 3. So we will determine if the given function f of x equal to x squared minus x minus 12 over x minus 4 if x is not equal to 4. Then 7 if x is equal to 4 is continuous at x equals 4. So we have piecewise function again. So apply again the three condition of a continuity of a function. So this condition should be satisfied so that we can say that a function is continuous. So let's determine if our f of x exists. So at if x equals 4, then our f of 4 is equal to 7. So based on the piecewise function, 7 if x is equal to 4. So 7. So we can see that f of x is defined at f equals 4. Then it's defined at 7. So next, we will determine the limit of f of x at x equals 4. So first, so we have the limit of f of x as x approaches to 4 is equal to limit of x squared minus x minus 12. So this is the function we use, the x squared minus x minus 12 over x minus 4 if x is not equal to 4. So we have, so next, next thing we will do is we will factor out x squared minus x minus 12. So we get x minus 4 times x plus 3 over x minus 4. So cancel out the x minus 4. So we have limit of x plus 3 as x approaches to 4. Then we will substitute 4 to our variable x. So we get 7. So as we can see, the condition 2 is also exists. And so now let's proceed to condition 3. So in condition 3, we will compare f of x to the limit of f of x as x approaches to 4. If it is equal, so we can conclude that a function is continuous. But if it is not equal, so we can say that the function is not continuous. So in condition 3, f of 4 is equal to 7, then it is also equal to the limit of f of x as x approaches to 4. So our f of 4 is 7, and also the limit of f of x as x approaches to 4 is also equal to 7. So therefore, our condition 3 is satisfied, and the 3 condition is satisfied. Then if it is satisfied, so we can conclude that the function is continuous at x equals 4. So it is continuous at x equals 4 because the 3 condition is satisfied. So this is what we will remember, that the 3 condition should be satisfied so that we can conclude that our function is continuous at a given point. So that's all, and thank you.